Welcome to my video. Please subscribe my channel. Our solar system isn't as isolated as it seems. Sometimes we get visitors from other star systems. On July 1st, 2023, astronomers spotted a new arrival, a faint point of light, moving too fast and at the wrong angle to belong here. This object, named 3I/Atlas, the I for interstellar, was only the third confirmed visitor from beyond our solar system. The first was the enigmatic Oumuamua in 2017. The second, 2I/Borisov, looked more like a typical comet. Each interstellar object is a rare opportunity, a message in a bottle from another world. With 3I/Atlas, a piece of another star system was coming straight to us. The astronomical community sprang into action, racing to observe it before it vanished back into the darkness. Every photon of light from 3I/Atlas was a clue to its origins. For most of history, everything we studied in the sky belonged to our solar system. Now we're realizing the galaxy is a dynamic, interconnected place. Objects like 3I/Atlas wander for millions, even billions of years before crossing our path. This wasn't just a rock. It was a physical artifact from another chapter of the galaxy's story. The universe had sent us a sample, and we were ready to analyze it. A cosmic mystery was unfolding before our eyes. Early telescope images of 3I/Atlas suggested a small icy object, just a few kilometers across. It fit our expectations, a dirty snowball, a classic comet, with a faint coma of gas and dust. The presence of a coma meant it was rich in volatile ices like water and carbon dioxide. Compared to the puzzling Oumuamua, 3I/Atlas seemed straightforward, a familiar comet just from another star. Scientists felt relief. Finally, an interstellar visitor that played by the rules. But science thrives on questions, not comfort. Ground-based telescopes can only reveal so much, and the true nature of 3I/Atlas was still hidden. Was its brightness just reflected sunlight, or was something else at play? To get real answers, we needed a more powerful eye in the sky. That's when the James Webb Space Telescope entered the story. Its observations would upend everything we thought we knew. The game was about to change. 3I/Atlas was about to reveal its true scale. The James Webb Space Telescope turned its golden mirror toward 3I/Atlas, and what it saw was astonishing. JWS detects infrared light, heat radiation, letting us measure an object's temperature, not just its reflected sunlight. 3I/Atlas was glowing in the infrared, radiating far more heat than a small comet could. The numbers didn't add up. This object had to be much bigger. New calculations showed 3I/Atlas was over 100 kilometers in diameter, 10 times larger than the object that wiped out the dinosaurs. This wasn't just debris, it was a planetesimal, a building block of planets. JWST's technology cut through the ambiguity, revealing a dark, massive, heat-retaining giant. The discovery was a shock. If something this big could be ejected from its home system, the universe is far more dynamic and violent than we imagined. Our solar system has objects this size in the Kuiper Belt, but we never thought they could be set adrift. 3I/Atlas forced us to rethink how planetary systems form and evolve. It wasn't just another data point, it was an anomaly rewriting the rules. The power of new technology had turned a curiosity into a headline discovery. The implications were immediate and profound. The galaxy is more chaotic and more connected than we ever realized. 3I/Atlas was a cosmic behemoth, silently gliding through our neighborhood, and it had a story to tell. The sheer size of 3I/Atlas challenges our models of planet formation. We thought only small objects got kicked out during the chaos of new solar systems, but 3I/Atlas, a true planetesimal, needed a massive gravitational shove, maybe from giant planets or a rogue star. Its existence hints at extreme cosmic violence in young star systems. If one giant was ejected, countless smaller objects likely were too. The galaxy may be teeming with interstellar wanderers of all sizes. 3I/Atlas is just the tip of the iceberg. 3I/Atlas changes how we see the space between stars. We once imagined it as mostly empty, with the occasional comet. Now we know there are boulders, and maybe mountains, drifting in the dark. For every giant we spot, there are likely many more, smaller and harder to find. The upcoming Vera C. Rubin Observatory will help us discover more of these hidden travelers. These objects aren't just silent wanderers, they're galactic delivery trucks, carrying material from one star system to another. Over billions of years, they seed the galaxy with water, carbon, and organic molecules. A massive visitor like 3I/Atlas can protect its cargo for eons, acting as a cosmic ark. The raw materials for planets and maybe life might not be local at all. The galaxy is an ecosystem, where chaos in one system sows the seeds of creation in another. 3I/Atlas is proof of this cosmic exchange. Thanks to JWST's spectroscopy, we know what 3I/Atlas is made of. Its light reveals a barcode of chemicals: water ice, frozen carbon dioxide, carbon monoxide, and methane. Even more intriguing, JWST found complex carbon-rich compounds, tholins, dark, tar-like substances formed by radiation. We see tholins on Pluto and other distant solar system bodies, but finding them on an interstellar visitor is huge. These complex organics have big implications for astrobiology and panspermia, the idea that life's building blocks travel between stars. A giant like 3I/Atlas can shield these molecules for millions of years. It's a cosmic messenger, carrying the ingredients for life across the galaxy. Studying its isotopes could even reveal the stellar nursery it came from. 3I/Atlas isn't just a rock, it's a galactic archive. It holds the chemical secrets of its birthplace. When a giant like 3I/Atlas passes through, its gravity stirs our solar system. Imagine a speedboat crossing a calm pond. The wake disturbs everything in its path. 3I/Atlas's gravitational pull can nudge comets and asteroids, especially in the distant Kuiper Belt and Oort cloud. It might send a comet hurtling toward the inner solar system, triggering a future shower. This adds a new dimension to planetary defense: unpredictable external influences. While a direct impact is unlikely, the indirect effects are real. By tracking orbital changes, we can even estimate 3I/Atlas's mass, using our solar system as a giant scientific instrument. The dance of distant comets could reveal the true nature of this visitor. It's a reminder: our solar system is part of a larger dynamic galactic environment. Gravity connects everything in the universe. The discovery of 3I/Atlas has sparked dreams of future exploration. Its size makes it a prime target for a dedicated space mission, maybe even a lander. Imagine drilling into ancient ice from another star system, searching for the building blocks of life. Such a mission would be ambitious, but the scientific payoff would be immense. 3I/Atlas is a testament to the power of our new astronomical tools: Atlas, JWST, and soon, the Rubin Observatory. We're entering the age of interstellar archaeology, ready to find dozens of these objects. 3I/Atlas reminds us we're part of a vast, interconnected galaxy. It challenges our theories, inspires our engineers, and fuels our imagination. This silent giant has traveled for eons to deliver a message. The universe is bigger, more violent, and more wondrous than we ever knew. With new tools and bold missions, we're finally ready to read that message. The stars are sending us their secrets. Are we ready to catch them?